Hello, it's Ben Holcomb here again. I'm back in the Dynamics lab and we're having a look at the data acquisition system and measurements that are made from the half-car rig. There's a previous video I've explained the operation of the 4 degree of freedom system, that's simulation of a half of a car. And in this video I'm just focusing on the measurement system that we use over here to collect the data from the LVDTs that are used to measure the displacements of the sprung and unsprung masses. We use a bespoke LabVIEW data acquisition system here. I can start the LabVIEW script by pressing the play button and we can see data immediately coming through here onto the screen. It's maybe a little bit not so clear to see there. In the settings tab I can change, for example, the sensitivity of the transducers that are specified. They've got a range between -5 and +5 volts, and we can define the slope in millimeters per volt so that we get engineering units in our measurement. Going back to the test data screen, here is a scoping of 4 channels of data. There's a red and a yellow trace here, a blue and a white trace here that are pretty much sitting on top of each other. Each of these 4 traces is for the 4 different laser LVDTs that are measuring displacement from the half-car rig setup. Once I have this sitting here scoping, it's essentially waiting for the event to happen. I've already picked the sprung mass up with the crane as I showed in the previous video, and now I'm going to release it from rest and we'll see the measurements be collected on the scope. So as I release it from rest, there you can see the measurements coming through. There's a beep as it triggers and collects those measurements. It's offering me the opportunity to save those data, but before I do that I'll just move that one out of the way. And here you can hopefully very nicely see on the video some oscillations. Right? So it triggered the measurement here, we're dropping it from rest. These 2 are at a high value, and then we see some very nice looking decaying exponential sinusoid looking measurements. Actually these measurements contain sinusoidal contributions from each of the 4 resonant frequencies, all 4 traces, in lesser or different amounts depending upon where those measurements are being made. Remember that I said that those 2 LVDTs on the sprung mass are not measuring the independent coordinates, they're measuring dependent coordinates. The measurements from the sprung masses, the smaller LVDTs at the bottom of the system, they are measuring directly the independent coordinates for those 2 degrees of freedom. Those are the blue and the white traces in here. The vibration is clearly a lot smaller. The spring is very stiff for the tyre, so we don't see a great deal of vibration. We do see some low frequency oscillation, which is coming from the sprung mass, but really we see the higher frequency vibrations in there, the shorter period, higher frequency vibrations of the sprung masses. They're lower amplitude, but they're definitely evident within these time traces. And we can process those time data using techniques like fast Fourier transform analysis to understand the natural frequencies of the 4 degrees of freedom. We can make configuration changes. We can explore the impact of those configuration changes on the resonant frequencies of the system, and that is the essence of the point of this exercise. I hope that's been a useful second video on the half-car rig in the Dynamics lab in the Faculty of Engineering and IT at UTS. My name is Ben Holcomb. Thank you.